Hello, hello, hello. Okay, so let's go. Stream live. Okay. So I was doing some research today, about 30 minutes ago. Yeah, let me not just lie. Well, I was just trying to read a little ahead of the stream, but I guess um, what I have prepared today. Yeah, so here's another nice resource to look at. I don't know. Is this C plus plus? Void I insert. Dum, 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 dum. Anyways, but one of the best resources I've used so far is from this website. I have it linked in the description below, so you can read it there. Hello? Yeah. Yeah. Yes. 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 Everything's okay. Sorry, I had an emergency to attend to, so let me quickly uh do that now. Get that out of the way, and we proceed with our studies. Mm-mm-mm. Just a minute, please. Um, I need to sort this out quickly, and then I'll done. Put my phone away for uh, the next 30 to 40 minutes of this stream. So, I think so. If you're new to um, date queues, I think you are in the right place because I'm also new to queues, right? I've not used queues before. I've been studying, I've read a little bit about queues in the past 2 days. Yes, 2 days. So, this is my third day on queues, and I'm going to attempt, solving some questions on LeetCode as well. And I've chosen this question here because it's kind of fun, and I just thought it would be a nice question to try out uh, while learning cues. So before we move into it, I'll just quickly sort this thing out. Uh, duh, 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 duh. Okay. Okay, so let's get started. How many lead code questions problems have you solved altogether? I'm not counting. I don't know how many I've solved, but let's see. I can check my profile here and see how many I've solved so far. Um, and most of these questions, I'll still need to, revise them again and solve them because, doing something once does not mean you actually know it, right? Repetition actually makes it stick. So, I'm not sure what's going on. This thing is not loading. Ah, let's refresh. Okay, good. So I think 73 questions, right? There's 49 here and 24 mediums. Yes, 73 questions so far. All right, so I will solve this question as well today. And let's see what we can do. Thank you very much. Okay. Oh my god, these people. I'm sorry, guys. I just Christ. Mm, mm, mm. Okay. Um. Hello. Welcome. Nice to have you in the stream. I think they are quite. I've wasted. Oh my god. I'm so sorry. I should have done all of this before I started this stream. Anyways, I'm going to just finish now. All right. Oh my god. What just happened? Come on, please don't do this to me. Ah, please. It's connected. Okay. My internet just gave me a a heart attack. Okay. Oh my god. Oh my god. Oh my god. I hope they don't shut down this internet. Okay, let's take a look at so now let's study for real. For real, for real. No more distractions. Um so I'll put this like this so it's closer to me. Okay. So we are going to study queues today. Now yesterday I made an implementation of queues using using stacks. I mean, sorry, using arrays and linked lists, right? So here is the code for that, and it is in the description link below, so you can have access to it there. Here is introduction to queues using linked lists. Although there are a few things to correct here, so we'll get back to that. But since we are not going to use linked lists today, we are just going to um, look at queues with arrays, right? And also, there's something fun I also discovered today, which is the I don't know how to say this, how to pronounce this word. Apparently, there's a data structure in Python, right? Or there's a module in Python in the collection module, right? Called I don't know, is this deck? Um, let me see. Kumar, yo man, good work. Thank you very much. Thank you. I will always, be here for you guys if you need me. I'm also studying, so it's fun to see other people in the same situations as me. So nice. Okay, so I will keep the chat off the screen for now, and then I'll respond after I'm done explaining the questions. Okay, so here is you know, so I also discovered this data structure. I mean this module in Python. It's called the doubly ended queue. Okay, so doubly ended queue in Python is implemented using the module collections. I mean the module collection. Well, the collection module. I don't know why they put module collection, but anyways, there's a collection modules in Python. In Python, there's a collections module in Python, right? And it is from that same collection we use something called a counter, right? And there are other fun, or useful methods that exist in the collection module. So you can see we have counters. I've not done this one yet. I've not used this here. I've not used this, all of these, name tuple. So far I've only used counters, right, from the collection module. Apparently there is also a deck. I'm not sure if this is deck or DQ, right? But this is not DQ for sure. So I'll call it a deck. So the deck is preferred over a list, right? In cases where we need quicker append and pop operations from both ends of the container, as deck provides an O of one time complexity for append and pop operation. I'm sure let me know, don't get me wrong, I raised two, right? The pop operation here is also O of one, right? Because we are popping from the front. So this is just a single operation. So this is also O of one. Now, what I was although I've not used deck, like I said, but one thing I think I know is that to use arrays, right, for queues, you would need to create um your own queue class, right, and then do all of this here before you begin using it, which I believe is a lot of code to write. But aside from that, I'm not sure yet what. Maybe there are some extra methods on the deck method from the collections module that are also useful, right? And but the point is, or the difference here is that if you are going to use your own queue class, if you are going to create your own queue class, then you have to implement the methods yourself, which I think the the deck functions from the collection module takes away all of those stress, right? So we simply use it, um, which also provides an O of one time complexity for append and pop operation. Yes, so appending to an array is also O of one, right? Or to a list in Python, if you want to call it a list. But appending something, it means adding an item to the end of the list, right? So that is also O of one time complexity. If I did this, if I run this pop function here, right, it means I'm removing the item in front, right? I'm removing this. So if I want to append again, right, I can simply do nums, sorry, not caps. I can say nums dot append, right? Append 4. Okay. So when I run this again, you can see I've appended 4. So this is not going to take a lot of time to do, right? At least it's just a single step operation, which means it's all of one time complexity. Now let me see if I did this, right? Let me say I pop and append like this. Would this work? Oh yes, it does. So it removes the first item and append it to the end. Well, okay. I'm not going to argue too much, but let's see. Let's continue with the uh this reading here. So this is the deck data structure. So for append and pop operation as compared to list that provides O of n time complexity. Okay, so we do that. Now add element at rare. We saw the rare and front yesterday, right? So rare is basically the item at the end of the, I mean, yes, the last item in the queue, and front is basically the first item in the queue. So rare and front are at distinct indexes as you begin to add items to the queue, right? But when the queue is empty, it means the rare and front I don't want to call them pointers, but I think at this point I will just stick to that. The rear and front pointers, right? They are the same position. When they are the same position, it means the queue is empty, right? Because we can't have, rear once. Sorry, front is always 0, right? Meaning it points to the first item in the queue. Otherwise, if it's 0, if there's no item in the queue, then it can still be 0, right? But when front and rear are equal, it means there is no item in the queue. So let me show you how that is done. So here we have this. I think so. When we begin to create the queue, right, we have the front and the rear set to 0, right? If we want to check if the queue is empty, right, we can do this. So I'll write a function that checks that. So we can say define is empty, right? Is empty is going to be a function. We don't need to take into, so we just say self dot queue, right? Sorry, we don't even need self dot queue. We can just say if, okay, return self dot rear equals to self dot front. Okay, so when we run this function, if it returns true, it means the queue is empty. So right now we have items in this queue. In fact, let me remove this and run this queue. Now you can see we have 1 2 3 4 5 6, right? Now let's say we run the queue is empty function. So I'll just say okay, I'll say print was okay, I call this my queue dot is empty, right? Now if this queue is empty, rear is going to be equal to front, right? So we'll have true, but if it's not empty, we'll have false, right? Now you can see false is printed here, right? Sorry, let's just add a new line, right? Print, can just add a new line like this. I'm not sure that's how. Okay, anyways, I'm supposed to do it this way instead. It's like that. Okay, so you can see we have false, right? Now let's say, let me remove all the integers from this array, right? What we'll have is true, right? Because no item were added to the queue, so the queue is empty. So that's just a quick recap, but let's continue, right? So rear and front are just the pointers that we use to perform some small operations and checks. So that's it. Input restricted so types of restricted deck input. So input is limited at one end while deletion is permitted at both ends. So it means we can insert in front and behind, right? Or rare. So okay, I'm not sure I'm pronouncing the rear, right? It's rear, not rare. Okay, rear. All right. So output restricted deck. So what can the deck return, right? Output is limited at one end, but insertion is permitted at both end. Okay, I don't know what that means, but let's see. Let's continue. So we can. Okay, so here is the deck function, right? I mean the deck method from the collections module. So I'll leave this here, right? We still need those. So I'll say from collection import deck, right? And then I'll say deck. I'll say new queue, right? New queue, new queue, and I'll say deck and pass its nums like this. You know what? Let's not worry about that. We'll print the queue here. Okay, let me break that there. I don't need to remove it because I might need it to explain something. So print new queue like this, right? Okay, so we see there's the function is still there, right? I mean, our array is still our list is still in its normal shape. Nothing has happened to it. But now I think there will be some methods that will be available to us to use from this deck method here. So let's say deck dot. Now you can see we have append, pop, extend, pop left, count, remove, index, clear, append left, right, copy, extend left. Okay. And yeah, so every other thing too is here. So that's really nice. Okay, so I think we can do let's do append, right? Deck dot append. So I'll say new queue dot append 7. So let's see what will happen. Okay, 7 was appended. I saw append left. What does this do? Append left 9. Okay, so it appends it in front, right? Okay, that's good. I think I mean we don't need to go through everything, but let's just look at a few things. So we have append, yes. So append and append left. I think pop, right? Delete an argument. I mean pop is used to delete an argument from the right end of the deck, right? So I'll say pop. Let's just do pop like this, right? Pop without anything. I'm sure this pop will just remove yes, so you remove the last item from the array. So let's say we pop I'm not sure if we can add in a value, right? We cannot. Do we? Are we allowed to do that? Yes, so it takes no argument. Okay, that's good. But what about pop left, right? It will remove from the front, right? Now let's see. Okay, yes, so that's what it does. Anyways, okay. Um, Index and all of that. So this is just self knowledge. You can the link to these resources in the description below. You can have access to it and read, to understand what is going on here. Now let's see. So append is O of 1. Append left is also O of 1. Pop O of 1. Yes. Index. I mean remove. Remove. Wait. Remove is okay. So I think the remove method also exists on lists where you try to remove an item from a particular index, right? Or you remove Okay, I think remove takes the actual value you want to remove, right? So let's say here we have norms. We created the deck, print deck. You know what? Let's just do it this way. I still have my norms, so I can say print. Okay, norms dot remove. Oh god. Okay, so you can see remove value, right? Remove a particular value. So let's say remove 3, and then uh, does this remove the value, and does remove mutate the list? Will remove mutate the list? I'll just remove this like this. So let's see this. Yes, it does. So when we remove 3, right, you can see 3 no longer appears in this array. Now, our original list is 1, 2, 3, 5. But after removing 3, so the remove function actually mutates the array. So this will be O of n time complexity, because this function has to search for which, first of all, if 3 exists in this list, right? So it to go from here, check until it sees 3, and then removes 3 from the list. Otherwise, you can use pop with an index, right? An index will just happen. I mean, popping will happen in a constant time complexity, which is O of 1. All right, so let's go ahead. And I think that's just something I really wanted to introduce to us. I mean, you can read these as well. O of k. Honestly, I don't know what this is. Okay, k might be a constant, right? Extend. You know, there is also extend on arrays, right? There's extend method. I think this is just, really nice, since we don't have to write all of this, extend, pop left, append left functions. So we can just use the deck method on the collections module. Okay, so I will come here. We have some questions here to solve. Now, this is the question I prepared for today. In fact, I just chose for today. I did not even prepare for this question. But let's see how we can solve this. I hope this is actually visible, or I should zoom in a little bit more. Right. Okay. So let's read the question, right? Before I read the question, let me check if there are any questions in the chat. Okay, so there are some comments. So keep the good work. I'm a beginner pattern. I just starting out. Okay. Good luck. Honestly, I like seeing, when people try out things and go for it. That's really nice. Keep studying. It is pronounced deck. Yes, thank you very much. It is pronounced deck. Thank you, EW. Okay, so there is. Do you follow any roadmap? I want to study too. Honestly, I don't follow any. I don't follow any roadmap, but there are, quite some number of things out there. People, I think the people should be allowed to get lost, and then find ways to do certain things themselves, right? So if you want to learn data structures and algorithm, obviously you will have to start from somewhere, right? And once you start learning something and you find out it is too difficult for you to understand, maybe there is something else you needed to know before that, right? You can just quickly reiterate, go back to it. But you can also look on my channel, right? So I have this. So I also get some information from other websites like LEETCODE. LeetCode.io. So you can check out LeetCode.io. But I don't really follow LeetCode's roadmap. I will follow it to some extent, but I think I made a combination of a lot of roadmaps to actually pick something that suits for me. Even now up to now, I still don't have a specific roadmap, so I just learn anything I want, right? But yeah, so it's still good to know arrays, string, linked list, all of those basic stuff before you move to a much difficult one. Okay. So Lively said hello. Yes, hello. Code Lively. Yes. Nice to have you here. Okay, so let's move on to the question. Now I'll read the question and maybe come back to the chat later on for any other questions. The school cafeteria offers circular and square sandwiches at lunch break, referred to by numbers 0 and 1, respectively. So there is a circular sandwich which is represented by 0, and then there is a square one represented by 1, or represented as. Uh, okay. All students stand in a queue. Each student either prefers square or circular sandwiches. The number of sandwiches in the cafeteria is equal to the number of students. The sandwiches are placed in a stack. Each at each step, if the student at the front of the queue prefers the sandwich on top of the stack, they will take it and leave the queue. Otherwise, they will leave it and go to the queue's end. It continues until none of the students wants to take the top sandwich and thus unable to eat. Right? Okay, that's really clear. You are given two integers array, students and sandwiches, where sandwiches at I is the type of ith sandwich in the stack. I is equal to 0 is the top of the stack. And J and student at J is the preference of the jth student in the initial queue, right? J is equal to 0 is the front of the queue. Return the number of students that are unable to eat. Well, I think after reading this question, or I read this question before the stream, and for the very first time, I have found a question with good description from LeetCode for the very first time. I'm not saying LeetCode, all LeetCode questions are poorly described, right? But this is the one I have seen that actually makes sense, right? It's easy to understand. So let's take a look at the example here. So there's students, we have a student array, and then we have sandwiches array as well. So now the student and sandwiches list, right? Basically, so here is the preferred the sandwich a student prefers, and these are the sandwiches that are available, right? So in this case, right, let me use my board as usual. I like writing on the board, so let's go ahead and do this. So I'll select this and remove that, right? So let's say we have it's very good to represent these things so that we understand it properly. Okay, so we have sandwiches, and we have the preferred sandwich of each student, right? Now I'll say this is ST for students, right? This is we are giving. Okay, so where's the question again? Okay, this is 1100. So we have 1100, right? And the sandwiches, I'll put SW like this. Okay, you know what? Let me represent that with a different color. So SW is going to be what? You know what? Let me just do this. I really want to uh visualize this so that I actually understand this question very, very well. Okay, I'm just going to represent this like this. Increase the size of this. Okay, so we are going to make use of this like that. Now, I'll represent a queue of students, right? Now, let's see what happens. So here we have this student here. What this question is basically telling us is, if a student in the queue, right, if the first student in the queue, right, if this is a representation of their preferred sandwich, right? So the number in this student's list, right, the number in front here has to match the number in front here, because the sandwiches are arranged in a stack, right? So let's say we have the sandwiches like this. So there's one sandwich. So I'll just do it this way, right? These are the sandwiches like this. Oh my god, I don't know how to draw. Okay, so I'll put that is every sandwich is represented. The this the round sandwiches are represented by 0, right? I want to, this is the ones that are 0, and the other ones are square, right? So one will be square, and then we'll have 0 as well, and then another square sandwich. So the students are here, right? And their preferred sandwiches are, 0 and 1 and so on. So I'll just remove this, and that's okay. Now that's strange, but okay. So let's say we also this. There's equal amount of sandwich for every student in the school, right? So I'll represent a queue of students. So I'll say this is student 1. Okay, let's represent them in blue. So we have one student here. Okay, I'll do it this way. I say one student here, right? Another student like this. Another student here. Okay, this is not how to draw human beings, but hey, it's just for the sake of studying. Okay, so you know what? Let me represent it properly, because I need to say add something inside here. So this is going to be like this. Their head is going to be a little big because I need to write something in their head. Also because they have to study. Alright, okay. That's probably not very funny, but yeah. So let's say this student here prefers, square sandwiches, right? So this is 1, 1, and this is circular sandwich. So I'll put 0 here and then 1. Now, here is every sandwich we have. Oh, I did this wrongly. I mean, the sandwich have to be arranged in this way. So I'll rotate the sandwich. I'll rotate the stack. Okay, yeah. Nice. All right. So, okay, this is good. The first student here prefers a square sandwich, right? So obviously, the sandwich at the top of the stack is not what they want. So they have to go back in the queue. They leave the queue and go back in the queue. So we'll do it this way. So I'll say this student here goes back in the queue, right? I'll just shift everybody back forward, right? Now, this student also prefers square sandwiches. So we can't give them this sandwich. So they go back in the queue, right? So I'm just trying to, visually represent what the question is asking us to do. Now, this student here prefers circular sandwiches, right? So now this sandwich here matches this student, right? Right, so it matches their preference. So in the case where we have 0, in front of the students list or the students queue, right? And in the student sandwich, in the sandwich list, we also have 0 at the top. So you can see there is a circular sandwich at the top of the stacks, and this student also prefers circular sandwiches. We take the students and give them their sandwich. So I'll do it this way. So these students get the circular sandwich here. We give it to them, and they leave the queue entirely with their sandwich, right? So now we have 3 students left. You know, sorry, okay, I made a mistake. I wrote 111 for every student. Uh, you know what? Let me go back quickly. I'll come back to this again. I don't what. How did I make that mistake? That's very funny. Okay. So we have 1100. Okay, not 111. Is 00. So I'll erase this. Is 00. Okay. Sorry about that. Um, okay, so let's go. Let's start over again. I'll bring this here. So this student prefers circular sandwich, and we have. This student prefers square sandwich, and we have circular sandwich here. So it goes back in the queue. Everybody moves forward. This student prefers square sandwich, but we have circular sandwich at the top of the stack. So it goes back in queue, and this student prefers circular sandwich, and there is circular sandwich at the top of the sandwich stack. So we give them their circular sandwich, right? And they leave the queue with their sandwich, so they are gone, right? It's got somewhere to eat the sandwich. That's a huge sandwich for one student. I'm spoiling my students. Okay, so this student here prefers circular sandwich, so they go back in the queue, right? And yeah, so we have now this student prefers square sandwich, and we have square sandwich at the top of the stack. So it comes here, and they take that sandwich and go somewhere, hide to eat the sandwich. Not sharing their sandwich with anybody. Now this student prefers square sandwich, right? So he goes back in the queue, and we move the next student. So this student prefers circular sandwich, so we give them the circular sandwich, and they leave the queue. And then there's one sandwich left at the top of the stack, the sandwich stack, and this student gets it and takes it and leaves the queue. All right, so that's basically uh, that's basically what the question is asking us to do. So whenever the preference of a particular student doesn't match the sandwich in the stack, sorry, the sandwich in the stack, they will leave the front of the queue and go back in the queue, right, until everybody is satisfied. Now, in the case where there is a sandwich left and that sandwich does not match the current student at the top of the stack, right, then it means that student will not eat, right? So let's say in this case, right, in this case here, we have 1111 001, and here, so there are 3 zeros, 3 ones, right? So it means there will be at least a number of students that won't eat here. So the preference of this one is 1, so they takes this sandwich. This person here will take this sandwich. This person here will take the 0 sandwich. It means we'll be left with at least 3 students that won't eat, right? Meanwhile, in this case here, every student gets to eat. So that's really awesome. Okay, so let's move on to coding this. Now, we'll need to use a stack, right? A queue to represent the queue of students. And I just showed that we can use the deck method from the collections module. So I'll use that. Oh my god, it's getting late and my time is almost up. So let's quickly write this function. Oh my god, I did not look at the the question here. So this is LEETCODE 1700, number of students unable to eat. So count students. So I'll call this 1700. So leet dash 1700 count dash students. Count students, right? Okay, so we do this. I'll copy this part and put it here. So close this, we don't need that. Import this module, this function from list. And so the first thing I will do is to represent a queue of students, right? So I'll say, I'll call the student underscore queue Kuwewe, and I'll represent it with a deck, right? So I'll say from collections import the deck, right? So this is just for us to have access to the pop, I think pop left and insert blah blah blah, all of those functions in the deck module. So I'll say deck of students, right? Now we will need to move students in front and back and so on, right? For that to happen, we have to run a loop, right? And what kind of loop do we run in this case? We'll need to run a loop with a while. We need to run a while loop because we need to keep this loop running so that the students will be able to move back and forth, right? Is it back and forth from front to rear, right? So if their preference does not match the current sandwich, right, they move back in the queue. So we need to say while the current student queue, right? So while there are still students in the queue, we need to do this operation. So here's what we need to do. We'll say if the student queue, right? So the student in front of the queue, the preference of that student matches this sandwich, right? So say sandwich in front. So this is the first sandwich. If this is the case, then okay, let me just say this. Right, we'll remove the student and the sandwich from the queue. So we'll say student queue, right? Dot. How do we remove? So we pop, right? We pop left. So pop left. Let's quickly verify that. I'm not used to queues, so let's say pop left will remove the students from the queue, right? Pop left and then print the queue. So we should have 235, right? So let's run this. 235. Okay, so we pop the students from the queue. All right, and also we'll need to remove that sandwich from the sandwich list, right? So, or the sandwich stack. So sandwiches dot pop. Again, we can use the normal function here, pop 0. All right. Now, in the case where the first students in the queue, right? The preference of that student does not match the current sandwich, then we need to move the student back in the queue, right? So first of all, pop left and then append it back into this queue here, student queue. So we'll say student queue. Can we do this in one line, right? If I pop left, just like I did it here, right? So we can pop and append. So print pop left. I'll do this pop left. Say student new dot append. Is it append left or append? Okay, append, normal append, right? And then pop left like this. So we should have 2351 printed. Okay, 2351 is here. Okay, this is good. So we can say students dot q dot so we first of all append. What are we appending? We're appending students dot q dot pop, right? Uh pop left, sorry, pop left. Okay, so yeah, so basically this is all we need to do, and at the end of the day, we'll return the length of students left, right? So say return length, okay, sorry, yeah, length of student queue. Now I know there will be some cases where students are, still in queue, and the sandwich available is not what they want, right? It's not in their preference list. So let's just test this out. This is just a basic implementation for now. I'll just say run. So we'll return this, we'll create a solution class, an instance of the solution. Now this nothing to do with the question itself, it's just what LeetCode sets for us, and I like using it that way. So say solution dot count students. So we use the first example, right? So say this here, let me move this to this side. Oh god, put this here and use this other one. So 0101, copy 0101, paste it here. So let's run this and see. We need to print the solution, right? Because we are returning something. So I'll call this results, and let's print this. Now this will only work because there will be no students left at the end of the day. Otherwise we might run into an infinite loop. But let's see if it even works. First of all, I'm too optimistic. Okay, so this is 0. It works, right? But in the case where the current student, right, is not none of the students want the, let's say we remove, we have students still in queue, and the sandwiches left, right, is not what they want, right? So in that case, right, we can do this. So we need to add some edge case here. We'll say if any will return if any of the students, right, any of the students left do not want the sandwich at the top, right, the sandwich at the top of the stack, right, then we just stop the loop, right? So if so how do we if any of the students, so any of the students means the available students in the queue, right? So say for, we can use a list comprehension. So we say so we can return students for return students for student in for okay so for in student queue. So say student queue like this, return student for students in student, what, for students yeah, so for students in student queue, right? Now student queue is the preference of the students, right? So if this student so for every one of these, if any student does not want the sandwich at the top of the stack, so sandwich at 0, right, then we stop the iteration. So break. Okay, we can break here and then still return the length of the students remaining. So that will be the number of students that will be able to eat, right? So let's say so copy this. I will duplicate this part, comment this one out, put here like this, and so we should have 3 students left in this case. So I'll run this. Oh my god, this is 5. Okay, that is not correct. So what did I do wrong? It should be 3, right? Wait. Pop left. You know what? 1, 2, 3. So this prefers that, right? So this will go back in the queue. Why is this still 5? I don't get it. Okay, so let's say if any of the students, oh, okay, do not want, right? Any, can you do this? It's still 5. If any, because this here will return true or false, right? If any of the students, for student, this will iterate for every student in the queue, in the student's queue, right? I think this here is stopping. So if, okay, so if not any of the students in the queue that wants this, yes, okay, that is. So if none of the students, any of the students wants the sandwich at the top of the stack, then we break. So any here will return, the result of this, right? So here this will be, this will either be true or false, right? And we want not any, right? Not any means, if we have false, then this statement becomes true, right? So, and then we break, which is why we have 3 here. Okay, so that's good. We can run this question here. We can run this here to see if we pass all the test cases. Dun dun dun. Okay, I'm copying the same thing. Not good, not good, Wilfred. I'll copy and just do it this way. Okay, so let's run this and see. Now the time complexity of this solution is going to be O of n. O of n squared. Is it O of n squared? Because we are not just iterating for every element in the array. Because of the fact that we are moving items back in the queue, right? It's going to be O of n. But anyways, let's see. Oh, are there any edge cases? There are not, but you can see it's really slow, right? It is very, very slow. It works, right? But it needs improving. We need to improve this solution. My time is up now. I think we can look into the improving part tomorrow. So I'll quickly, submit this git add git. I'll call that a brute force solution because that's literally how I thought about the question, and I also showed you guys on my illustration page. So yeah, so commit dash m. This is queues, right? Queues, and this is LEETCODE dash 1700. Okay, so I'll say git push come on, origin main. Alright, so that is done for today. I need to go now. Oh my god, there were a lot of people here. I'm so excited to have you guys. You just have an error. Oh, okay. Code life, you said I have. You get TLE. Yeah. TLE is when you run the loop, an infinite loop, right? What's TLE? Anyways, so again, that is a slow implementation. I'll look into how I need to improve this, but um, honestly, it was good to have you guys here. Um, and you know, please don't forget to keep studying. Every day, and show up for what you're doing. So there is YouTube Kunde says go type. Hello YouTube Kunde. Nice to have you here. Yes, Code Lifey. Oh my god. I'm actually time limit exceeded. Thank you. Time limit exceeded. Okay. Yes. So um thank you for actually sticking to the end of the stream. This is awesome. Right? Code Lifey. Thank you. Um I'm I'm just so tomorrow I think we'll look into uh you know resolving the slow implementation. Otherwise, I think the solution works. And also for anyone who wants to look at the solution, you can have the link in the description below. I think that there should be a better way for us to interact aside from the live stream. I think somebody made a suggestion sometime to create a Discord channel. Um, I'll look into doing that sometime this week. I keep saying sometime this week because I don't have the time actually to do that. But anyways, anytime from now till whenever, right? I will do that. Okay, so again, it was good to have you guys on the stream. We'll continue with more Q's question tomorrow, and I'll see you guys. Bye. Stay coding. That's my sign out. I don't know if I should say that. Anyways, um, yes. So, code life is here. I think you can. Yes, that's quite right. But you see, the thing is, for every data structure, right? I think there's a need to go through the easy questions, and it's so funny how LeetCode actually ranks their questions because sometimes some medium questions are very easy and some easy questions are very difficult. So I don't know, but yeah, stay coding. All right, bye.